4.5, combinations. Now, a combination is a grouping of objects where order does not matter. So, for example, two objects A and B have one combination because A, B, and B, A are the same. The following questions are not difficult, but what makes them difficult is that you have to distinguish whether or not something is a permutation or a combination. Let's just take it off to the side here for a second. So if I were to have a group of kids, so kid A, kid B, kid C, and if I were like, okay, so I'm going to pick groups of 2 from here, how many different groups of 2 can I make? Group AB, so Alistair and Bonnie, are the same group of kids as Bonnie and Alistair. So this one right here would be a combination because order does not matter. However, if I said groups of kids, if I were to say how many different groups or groupings can I make from 3 kids, if one person has to be the president and one is the vice president. Okay, that means that Alistair being the president and Bonnie being the vice president is different from Bonnie being the president and Alistair being the vice president. Okay, so this question would be a permutation. Whereas if we're just talking about groupings of kids, Alistair and Bonnie versus Bonnie and Alistair, it's the same thing. So this would be a combination. So today we're just going to focus on the combination end of things. And in fact, we'll find that there are fewer combinations when order does not matter than permutations where order does matter. The difficulty comes in when we have to distinguish whether the question is a combination question or a permutation question. And that will come later. But just pay attention. Order does not matter in a combination, whereas in a permutation it does. So before we calculate combinations, I just want to take some notation down. So when order does not matter, we use the notation NCR, which is very similar to our permutation, which was NPR. Or we can see it in parentheses and having a vertical orientation here, and choose R. Or we can use the formula n choose r equals n factorial over r factorial times n minus r factorial. You'll notice that it's very similar to the permutation. Okay, the only thing that's different is we have this extra dividing out by r factorial. So, given that we know this this formula now, let's apply it to this question here. So determine the number of 3-person teams that can be formed from 9 volunteers. So it's just like teams. Okay, so Bobby, Joe, and Sally are the same team as Sally, Bobby, and Joe. Order does not matter. So that's when we would use our combination. So we would use N, C, R, where N is the total number that we can pick from, which is 9. And the R is how many we want to pick, so that's 3. So I would say 9, choose 3, and I'm just going to do the whole spicy meatball for this question here. I'm going to put it into the formula. So I'm going to remind us that the formula is n factorial over r factorial times n minus r factorial. So that means that we have 9 factorial over 3 factorial times 9 minus 3 factorial. That's 9 factorial over 3 factorial and 6 factorial times 6 factorial. I'm going to expand this one out, so 9 times 8 times 7 times 6 factorial, because I can cancel that out with a 6 here. 3 times 2 times 1 times 6 factorial. These guys cancel here. 3 goes into 9 3 times. 2 goes into 8 4 times. So the total number is 3 times 4 times 7. So 12 times 7 is going to be 84 ways. Okay, so let's just, as a comparison, let's figure out what 9 pick 3 would be. Let's see the relationship between them. So if I were to say 9 pick 3, I would get 504. What I wanted, the only difference between the permutation and the combination formula is this r factorial. Okay, so if I were to say divide that answer by 3 factorial, which I know is 6, but I'm just going to punch it in anyway. Look at that, we get 84. So if order didn't matter, so if Bobby, Sally, and Joe is a different 3-person team than Sally, Bob, and Joe, then we would have 504 options, but we're dividing by an extra 3 factorial, so we get that 84.